That one was a little harder to get to. Yeah, the truck's covered in water, so I'm trying not to get fried here. But here's the last part we're going to test. Trying to get to the small post. So this is the S terminal, so the signal wire coming from the ignition itself. So when I turn the key, it relays that small amount of current to control the bigger amount. So I'm trying to get on that terminal to do a voltage drop test on that. Same rules apply, only there's something different. So we notice I'm on the positive side, and I'm also on the S terminal, but it's reading 12.5 volts. There we go, 12.5 volts. Here's why though. The circuit's not live, so since I'm on that post, guess what? That's acting as ground. So this is normal. I should read 12.5 volts right now because I'm on the positive cable. I'm going down to the signal, but right now, there's no signal. So it just acts as ground. So when that circuit's open, it acts as a ground. So right now, even though I'm reading 12.5, here's what should happen. Once I start cranking the motor, this should drop down to 0. So this is the only time where it kind of confuses people, like, oh, I got 12 volts. Why do I have that? I'm not on the ground. So it's ground until you actually get that signal down to the cable. So this should drop down to almost 0. If it doesn't, if it's above 0.3, then like I said, again, we have unwanted resistance or corrosion or something along those lines, and we need to think about that later on. But right now it says 12.5, should drop to about 0. So here we go. Last test. Let's see what we get. Still out a little bit of fuel in the cylinders, it seems like. But that's all right. So, again, we're bouncing back to 12 volts. Like I said, that's normal because when it's open, it acts as a ground. It's grounding against the case pretty much. I guess you guys are going to tell me, did this drop down low enough? Did you see what actually happened on the screen? I know it's a little far away, but I mean, I'm going to watch the video again, so I'll be able to tell you either way. You know what? Tell you what, this whole quarantine thing, candy's where it's at, though. I'm gonna have a York peppermint patty because I like to support, local business up in York. But tell me what you guys think. We're gonna have this in a Zoom session either way, so hopefully I made this a little more fun for you guys. Here, let me move the camera a little bit. But those are just some basic tests you guys can do. So when I'm talking about the basic tests themselves, I'm talking about, okay, so for those of you who are not quite grasping what a voltage drop is, here's what I'm looking for. So let's say I did get something that was more than, let's say 0.2 volts, like 0.3 volts. Maybe I would have discovered, hey, this battery terminal has corrosion on it. Or maybe this engine's ground wire is frayed or cracked and the engine's not a good ground. Or maybe I have really high resistance in the control side of the circuit. So maybe I have a broken wire, maybe I have something drawing too much resistance in the wire coming down through, whether it would be the neutral safety switch or the relay maybe, or anything like that. Because the relay, just like this guy here, I still have a starter relay as well. That's in the fuse box as well. So that's going to be the same principles. Still have a relay even though we have a solenoid. But anything like that, so those are the most basic tests you can do with a digital voltmeter. Just to eliminate, if we're looking for resistance, that's one thing we could do. Obviously, if you have like a no crank situation, you still should do some of these tests. Obviously, if it doesn't crank, you're not going to get that 9.6 volt test. But it can tell you, if let's say right there on that last test, let's say either the relay clicks or it doesn't click at all, and that still remains 12 volts. Well, now I know, hey, it's on the control side of the circuit. That's where I got to start my testing. So then I could voltage drop from that S terminal and work my way through a diagram all the way up to where I pretty much put the key into the ignition. So it kind of points in a direction. Doesn't tell you what's wrong, but it shows you, okay, it's this part of the circuit, or I have to do testing here. I have to start here and then work my way down. So, like, let's say if I did get nothing changed, and let's say it dropped to like 11 volts. So I have what? Okay, 10 volts worth of resistance happening before it comes down to ground. Maybe if I were to go up that wire, maybe I'd find maybe a rat or something chewed all but one strand of copper left in that wire. That's the type of stuff that I would go after. So just going up that wire. From there, I go to the next connection and then take the lead, put it there, do a voltage drop again, try to start it, and then I just work my way across. So just like in the ATEC trainers, that's what you're trying to do. You're trying to just work your way across, find where that resistance is. If you have that voltage drop that's extreme, it's resistance. It's resistance, and you just have to trace out where it is. There's rule of thumb specs for what should be drawn through, like a relay, a fuse, a motor itself, but those are some of the basic tests you can do with just what you guys got here. So this is just a multimeter. I did 3 basic tests, technically 4 with just testing and cranking the battery, but like I said, all I removed was the fuel pump relay and the injector fuse, because we still had some fuel in the rail, so it was still trying to pump that into the cylinder. That's why it was kind of like stalling and trying to start, but it didn't really start. So we have those options. Like I said, my Acura wasn't the best because that car is too smart. It knows, hey, you took that out and I know what you did. So that's a harder one. But some of this stuff, like the Chevy trucks I work on all the time, these are easy ones to do. The starters are pretty easy to get at, so it wasn't too bad. But we're going to kind of keep discussing how the starters kind of work. But this is one of the basic tests that for you guys next year, you guys should be able to do. And employers are going to expect you to be able to do this and kind of trace your way back through a circuit if you are like trying to determine a problem. So there you go, just a DVOM, pulling some fuses, and what we spent, me talking to you guys, a total, maybe this was 20 minutes worth of video, 25 minutes worth of video. Honestly, in the shop, I could pull this truck in, I would know what fuses and what relays to pull out. From there, I'd go boom, 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 and I would have my answer. Okay, I have to go this way, or I have to go this way. So I would at least have a direction of, hey, it's this side of the circuit. There's a problem in this side of the circuit, and then I would have a route to go within probably like 5 to 10 minutes. So 5-10 minutes of diagnostics just to start off, and then from there you can kind of start making an assumption or a hypothesis of what you think it might be. That's not too bad. So just with DVOM, that's what you can do. So I'll see you guys later.